Okay. All right. So let's now continue this solution of ours in example number 3. So let me just check if you guys are already in front of your computer. So just give me a thumbs up. Mhm. Okay, great. So as you guys can see, after forming these equations right here, so it is now completely to you which process you're going to use. Is it simultaneous equation or via calculator? So either of those two, it will give you the same answer as long as you have the correct, solution or correct expression or equation. Okay. So in here, I will not solve this one anymore since we don't have that much time anymore. And we are still at slide 29 and then we still have more slides. So uh, I think we cannot finish the the third module already. The fourth module rather, since this is, uh, ah, this is the module number 1 and 2. My bad. This one was supposed to be module number 3. Yeah, that's correct. But why is it module number 2? Why is the name of my... Anyway, this one is module 3. Okay. And then the next one is module 4. So for the third example, where is that one? So you will get this equation right here for the ABC, the outer loop. And then for the ABD, you will get this one. So let's compare if they are the same. So equation number 1, okay, which is this one. So 12 minus 4I1 minus 12I3, which is correct. And then for the second equation, the outer part, so we have here 12, okay, which is already transposed on the other side. And we have here negative I1, 4, which is correct, and then negative I2, and then 6. Okay, this one is just already transposed on the other side. So that's the reason why this one is already positive. Okay, but anyway, so we have these equations right here. And then here is the simplified version of that one using or with having those values. And then after that, you can now apply two simultaneous equations. Okay, so in here, I did show the solution for the two simultaneous equation. So I did multiply the this equation number 1 to 4, and then this one into by 1. So I didn't do anything. So why did I do that one? For me to be able to eliminate the I sub 3. So after eliminating the I sub 3, then you can now have one unknown only, which is the I sub 2. So after that, you can now find the value of I sub 2, which is 1 ampere or 1 amp. Okay? So after getting the value for I sub 2, you can actually substitute this one, okay, either of those equations. So this is another way for you to be able to get the value of your I sub 3. Okay? With that, you'll be able to get the value of your where is that one of your I sub 3 right here, I sub 3, which is 0.5 ohms. But in here, I just I became consistent wherein I did apply again another simultaneous equation. So I did multiply the first equation by 4 and then the second equation by 10. So with that, you will get the same value for your I sub 2. So that you can now eliminate this one, and then will give you one unknown variable only, which is the I3. And then simplify this one a little bit more, and then you will get the value of I3 as equal to 0.5 amp. Okay, and after that, you can now use the value of I2 and I3 to get the value of I1. So 1 plus 0.5 will give you 1.5 ampere. Okay, so you can verify this one using Ohm's law, of course. Okay, so try to combine this one using parallel law and then get the total current. and try to compare if you will get the same value, which is 1.5 amps right here. Okay, so were you guys able to get the concept so far and how to solve the uh, example number 3? Okay, so I didn't ask if you guys were able to get on how did you get those equations. That's because of course we didn't do those anymore. Okay, so I will leave this one as your uh, self study exercises. So that's the reason why I only asked you guys if you guys were able to get the concept. Okay, that's the important thing and how to solve a certain circuit, and you're going to apply Kirchhoff law. Okay, well, anyway, just go here again later on after this discussion. Okay, just read everything again and then try to do that one on your own. So that's why this one is very big. I highly recommend you guys to redo this one using an actual paper. Okay, and if ever that you cannot still not understand anything, so feel free to message me so that I can give you more advice and then I can give you more reference maybe on how to solve using a Kirchhoff's law. Okay, so that's it for this example right here. So this is just another concept. Okay, so we have loop number here. Of course, we only have loop one since this is a one closed loop. Okay, but more explanation when it comes to summation of voltage, just equal that 1 to 0. So I will leave the reading part to you guys. The same with this one. So Vs plus minus I. So this is just basically the uh, voltage or the KVL law. Okay, so with this equation, so it's negative since this is a voltage drop. Okay, and then by transposing those two on the right side, you will get this new equation right here. Okay, and then since they are in series, so we have one value of current only. So you can also do this one right here. Okay, so put the I on the outer side and then multiply that one on R1 plus R2. So after combining those R1 and R2, you will realize that it's actually the R total already. So you can also do this one right here, I times R total, wherein R total is R1 plus R2. Okay, and then in here, you can also do this one using this I is equal to V divided by R. Okay, so V divided by R total, which is R1 plus R2. So if you want to get the individual voltage of R1, so it's VR1 is equal to I times R1. Okay, so initially we only have I, which is the Vs divided by RT, or this Vs divided by R1 plus R2. So we can use that one to replace this I right here. So Vs, which is this one, times R1, which is now this R1 right here, divided by R1 plus R2, which is now the R1 plus R2 right here. Okay, so it's just a matter of manipulating, okay, your equations right here using Ohm's law, okay, etc., etc. And then if you want to get the VR2, then you can also do this one. Okay, so the only one that differs is the numerator. Okay, so let's have an example using this diagram right here. So we have, my bad. This one is 2 resistors only, but this one is 3 resistors. Anyway, so let's do this one using the paint. So we have here a voltage source of 12 volts. And then the first one is 10 ohm. Second one is 20 ohm. The third one is 30 ohm. So again, sorry for my ugly handwritten. Anyway, that's the circuit for this one. And then calculate the total resistance, the circuit current, the current through each resistor, the voltage drop across each resistor, and then verify that one using Kirchhoff's law. Okay, so here's the solution explanation. So of course, just by adding everything, 10 plus 20 plus 30, you'll get the R total, which is 60 ohms. And then for the total current, of course, we already have the total voltage and then the total resistance, and you can already use that one. So I is equal to 12 divided by 60. will give you 0.2 amps or 200 milliamp. Okay, so those two are just the same. Okay, so that's it for the A and B. And then for the letter C, so we can already solve for the individual currents just by saying that I total is equal to IR1, IR2, and then IR3. Since they are in series, so you only have one single value for the current. The same with the voltage drop. Since they are in one connection only, so you have the same current 0.2, 0.2, 0.2. The only one that differs is their individual resistor, so that will determine how much voltage drop it will consume. So for the R1 it will give you a voltage drop of 2 volts. For the I2 it will give you a voltage drop of 4 volts. For the R3 it will give you a voltage drop of 6 volts. Okay, so yeah, that's basically it on how to solve this example number 4. So did you guys get the idea or the concept? Okay, what about the others? So please type also how many percent, just a little, sir, you know, any feedback will do. Okay, as long as you have a feedback, that's already a big deal to me. That only means that you are really listening. Okay, like unlike the others. So I'm not really sure if they are in front of their computers right now listening to me. Anyway, so I'm glad that there are still at least two or three who are, uh, how do you call that one? Mm, masipag, okay, or dedicated, yeah, still dedicated in learning this topic. Okay, all right. So more solution explanation, etc., etc., or how to verify this one using Kirchhoff's voltage law. Okay, so we just simply did a one loop, course the original voltage source, and then three voltage drops, and then those given values, and then the result, and then 12 minus 2 minus 4 minus 6 is equal to 0. So if this one is equal to 0, meaning those values of yours are correct, or those process of yours that you did in here are actually correct. Okay, and then here's the labeled diagram. Okay, so the voltage source, the current that is flowing, and then the voltage drop, okay, or the voltage across. So maybe you guys are wondering on what is the difference between voltage drop, voltage versus voltage across. Okay, so well, actually they are just the same. So voltage drop is the voltage that this component accumulated. Okay, the same with the voltage across. So this one is much more straightforward, since the voltage across through this resistor is 2 volts, and this one is 4 volts, and then this one is 6 volts. So if you're hearing, let's say, alternating words when it comes to voltage drop and then voltage across, they are just actually the same. Okay, so just to avoid confusion when it comes to those terminologies, drop and then across. Okay, and then here's I think the theory behind blah 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 blah. So just a summary, okay, about Kirchhoff's law. Okay, so here's the reference as usual. My bad. This one didn't came from All About Circuit, but this one now came from all electronics tutorials. Okay, so just visit this one if you want to see the complete version of my examples right here. So yeah, that's it for the module 2. So what we'll do next meeting is, if you guys are willing, okay, if you guys are willing, we can actually have up to part 5. because I'm not really sure if we can finish 3 modules next meeting. But supposedly, we'll be able to finish the module 3 and 4 today, but I don't know what happened. We are too slow right now. So yeah, basically the main concept of Maxwell, 80% of it came from the Kirchhoff's law. So that's the reason why, after learning the Kirchhoff's law, you will be easily understand the Maxwell as long as you were able to understand the Kirchhoff's law. Okay, so I highly suggest you guys to master first the Kirchhoff's law before jumping in and then start learning about Maxwell. Though I I'm making sure that once you've learned the Kirchhoff's law, everything now is super easy in Maxwell. Why? Because using Maxwell instead of Kirchhoff's is a lot easier. Okay. Well, we'll discuss that one next meeting, so you will know next meeting what are your differences. Okay, but 80 to 90% they are just the same. Okay, same concept. So yeah, that's it for today. So since we are already done with the module 3, then I guess you can now start uh, practicing, especially this one, 2, and 3 for the active jobs. Okay, then if you want, you can also visit these 3 practice exercises and then have an advanced study with the module 4. So that's also okay. That's actually perfect for me. So that once we have the next meeting, you already have an idea how to apply the Maxwell. Okay, and if you want, you can also start answering the Kirchhoff's law quiz. So this is 110 points. So the due date is July 5. So don't you guys worry. You guys have plenty of time. You guys have 1 week, before uh, end up and lose time before you can take this one. So as early as of now, I would like you guys to do a lot of practice, especially in Kirchhoff's law. Okay, because this one is 110 points. So after you're done in analyzing this one, then you can now start analyzing the Maxwell. And you can now also start answering this one if you want. Okay, so it is completely up to you since this one is already open. However, you will only have one attempt, of course. So having a second attempt is not allowed, of course. So whatever is your score on that first attempt, then that's already it. We cannot do anything about it anymore. Since giving you a second attempt is considered as cheating already. Okay. And do not also forget to answer the case study number 2. Alright, so just read the facts and then the question and then just share your opinion with that. Okay, so I guess that's already it for today. So do you guys have a question so far or clarification?
Wala naman po, sir.
Okay,
Wala po.
so sorry. It took us longer than I expected. Anyway, so just continue the module for next meeting. Okay, so if you guys don't have a question anymore, then you guys may now go and then let's just meet again next meeting. Okay, so goodbye and thank you.
Thank you, sir.
Thank you too.
Thank you, sir.
Thank you
Thank you,
too.
sir. Goodbye po.
Thank you and goodbye too.
Thank you po.
Welcome.